Hey y'all. All right, real quick ed puzzle on synthetic division. And it's pretty tough to talk about synthetic division without talking about long division. We are going to do a little bit of long division next week, but I just wanted to show you an example of a quadratic, 2x squared plus 7x plus 9, divided by x plus 2. And then just share like what the answer should look like at the end and so on and so forth. Okay, so I'm just going to highlight this real quick. This is going to be like 2-3 minutes. So when I take 2x squared plus 7x plus 9 divided by x plus 2, I could do old school division. We're going to, break this down compared to regular division in grade school. Putting the old division garage here, 2x squared on the inside, x plus 2 on the outside. And then you ask yourself, back in grade school, what times this equals this? And then you put it up here. Well, what you focus on is what times this equals this. And you know what? We're going to go over this a little bit more on Monday. If you don't get this, that's fine. I just want to compare this to what synthetic division will look like and how it really shortens our process. Anyway, what times x equals 2x squared? 2x. And then you go ahead and hit 2x times x and get 2x squared here. But you also distribute 2x times this 2 and get 4x. Now, why are these minuses here? Because then you subtract. That's part of that grade school division when you're dealing with that division garage kind of situation. And then this ends up being no remainder here for the x squared position. But now you end up with 7x minus 4x, which is 3x. And then you go through the same thought process. What times this? Oh, blue and yellow make green. Little math colors. Right, make this X here again. Using my mouse, that's why it looks a little rough there. But what times X equals 3X? 3. But then you distribute it. 3 times X is 3X. 3 times 2 is 6. Then you subtract, which you distribute that minus sign. Then you get a remainder of 3, and then we're hoping you remember back in grade school when you learned about where fractions came from. The remainder you put over what you divided by as a last situation. But in polynomial world, you have to make it a term after that. So 3 divided by x plus 2. So final answer of this division statement, 2x plus 3 over x plus 2, remainder over divisor. Okay, just maybe understand that's what the answer is supposed to look like. So then we can compare it to what synthetic division is. And yes, this is the same question. 2x squared plus 7x plus 9 divided by x plus 2. And then we're hoping you CAT students remember that you did synthetic division quite a bit in Math 2 or Math 3, probably Math 3. Right? So step 1 for synthetic division. Again, hopefully this is a review and reminder. And I just wanted to look at the long division answer and compare it to what the synthetic division answer is. The same. So what do you synthetically divide by? The 0 of x plus 2. So you're supposed to set this equal to 0 and solve. And you get negative 2. And that goes in the synthetic division bar. You take the coefficients of what you're dividing into, 2, 7, and 9 in order, and write them just as coefficients without the x squared x. Well, and then it's a constant. First step is to bring down the 2, must have a starting point. Then you multiply and add. So negative 2 times 2 is negative 4. Add. 7 plus negative 4 is 3. Multiply again. Negative 2 times 3 is negative 6. Add 3. And then understand this is what's called a depressed polynomial. Everything goes down by 1 degree in the answer. And the last term is the remainder. And you're supposed to put the remainder over the divisor as a last term. So that's all we're doing today. We're doing synthetic division and writing the answers out in what's called fractional form. where you take the remainder over the divisor as a last term. So hopefully you remember this. And also remember that this only works when you have you're dividing by a linear divisor, a divisor that's x plus a number, x minus a number. If you don't have that, then synthetic division doesn't quite work unless you do something special. And that's why we still have to teach long division on Monday or Tuesday, depending what day you are, because it doesn't always work. Okay, so we're just going to divide using synthetic division on these questions, and you're going to get a lot of examples because it goes fast, actually. It's actually a really easy process. If I'm going to synthetically divide by x minus 5, then you are going to synthetically divide by 5. Don't mess that up. Check if there's any missing terms, x cubed, x squared, x constant. Nope. 5, negative 28, 14, negative 5. Bring down to 5. First step. That's how you get started. And then you start your multiply add situation. Multiply, add. Negative 1. Ooh, close. By the way, I should tell you this. If that was like 5 and this ended up being 0 here, then this would be considered a factor of that. That means it would divide into that evenly with no remainder. Ooh, giving you some extra information there. Unfortunately, it didn't happen, so we do have a remainder. Now remember, this was an x cubed. I like writing the terms above it or what it represented in the polynomial. And now it gets knocked down 1. Everything gets knocked down a degree. Oh, I'll make that plus negative, minus 1, and then remainder divided by divisor is the last term. So that is synthetically dividing and seeing what's left over after that. That's why I showed you this. It's taking the place of this long division. Much faster question now. We have to do long division though, because sometimes we divide by not a linear binomial. I couldn't think of the word binomial right now. Yikes. 4, 3, 2, 1, 0. No missing terms. So x plus 4, I don't think I have to show that. That's negative 4. Set it equal to 0. Solve. 30, 23, 4, 20. Bring down to 6, starting, and then you start multiplying, adding. Hopefully not going too fast. Negative 1, 4, which is 8, negative 32, negative 12. Okay, remember, depressed polynomial, 6x to the third, and then 6x squared, minus x plus 8 plus negative 12 over x plus 4. That is the division statements. Okay, then these last couple, just be careful. X to the fourth, x to the third, x. You cannot not account for this. I know double negative. You must account for missing terms for synthetic division to actually work. So x minus 4, 4. 6, negative 25. No 0 here, no correct answer. Oops, I don't want to put a plus there like this is some sort of term. Just want to separate them. So this is imperative. You have no choice. I mean, just think about it. If you multiply, add, and you have this missing position, you're going to have a different completely answer at the end, and you're going to miss the x squared position. When you write the depressed polynomial, you're missing a spot, and it just doesn't work out. So must be careful. 24. Again, one more time. You have to have this missing position accounted for. You don't do it, you get wrong answers. Negative 7, negative 28. 8, negative 2. Okay, so 6x cubed. What? 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 Well, this is fun. You just saw me write it 5 times, maybe 4. 6x cubed. Oh my goodness. That is fun. I love computers. Third, minus 1x squared. Keep writing. Come on. You can do it. Oh my gosh. Oh my gosh. There's something going on here. Yay. This is awesome. Minus 4x minus 7 plus negative 2 over x minus 4. Good times. And then notice this one. Cubed, x squared. Oh no, missing an x. So you synthetically divide by 2. There's nothing else I can say. Just do it. X minus 2, 2. Okay, 4, negative 5, 0, negative 2. You're missing an x term. So you can put a 0x in its place, and you need it for synthetic division. Bring down the 4. This 4 is 8, 3, 6, 12, 10. Hopefully the pen works. 4x squared. Everything gets knocked down 1. Very simple process. And then we're going to talk about Monday and on more applications of synthetic division and what it can do for you. All right. It's been a pleasure and an honor again.